let me see. I'm going to do the next few steps on this number 2. So now if I throw all my stuff in here, so here's f of xi times delta x let me see if I can. So if I go ahead and distribute and break up the sums, let's see if we can do that. So this will be negative 27 I squared over n squared plus the sum 27i, oh, it should be n cubed, sorry, 27i over n squared, right, n squared times n, and then plus the sum I equals 1 to n, 12 over n. So I distribute and I break my sums up so then I can look at each piece separately. And you can see there's going to be where the I squared comes in. That's going to be where I need this. So let's see if we can do this. So this one, the negative 27 over n cubed, can come out. And the sum of I squared is that n plus 1, 2 plus 1 over 6. So the limit as n goes to infinity of I squared is right there. And the 27 over n cubed is a constant. So it just is outside of that. Notice that the degrees of these are the same, but the coefficient on the top is 2. So 27 over n squared comes out of this one. And what's the sum of I? That's that little Gauss dude. And then finally here, the 1 over n can come out. What's the sum of 12? n times. Yeah, that's the basic definition of multiplication. Yeah, 12n. So what's the limit of these going to be? Well, it's going to be 2, because the coefficient on top is 2 and the coefficient on the bottom is 1. They're both degree 3. All right, so that cancels with that. And so this first piece is negative 9. The limit of this one, these are going to go to 1 because they're both degree 2 and they both have a coefficient of 1. So then I get 27 halves. And then this one is just going to be 12. So I get 33 halves, or 16.5. I like it. You've never seen this process before today. So maybe it's not crazy hard, but it's very new. So you just got to let yourself try a few examples out. Let's do number 3 and then I'll come back and do number 1, because number 3 is talking about this guy. This is just pointing out what we're going to do maybe a little bit today, and we'll see. This seems to have no connection at all, but we're going to have to make this connection. Right now, I just want to remind you, so we got that section about antiderivatives. What is the antiderivative of this? X squared would come from, no, the antiderivative. So x squared would come from x cubed, but it's got to have an over 3 to kill that 3 that would want to come down. Where would x come from? And it's got to have an over 2 to kill that 2 that wants to come down. And of course 4 comes from 4x. So I'm going to leave it up to you. If you do f of 3 and you subtract f of 0, you do get 16.5. Notice that the constants would cancel. I don't know what it is, but since I'm subtracting these two, the constants will cancel. So there seems to be, this is nowhere near enough for proof, but it seems that there's a connection between the antiderivative and this area finding stuff we're doing. So that's a connection we still have to make. So that last part was just antiderivative and then plug shit in. Of course, 0 is easy. Everything's 0 except C. And then the very first thing that was on here was to get an estimate to get things started. So if I want to use 4 rectangles, what would the width be up here? 4 goes underneath, right? So it'll be 3 over 4, so 3/4. Drawing the rectangles, so I'm using left endpoints. So what would the first rectangle's height be? In fact, where does the first rectangle go from to? What's at the base of the rectangle? It's from what to what? Where's this region starting? 0. Every step is 3/4. So where's that first rectangle go? It goes from 0 to 3/4. The next rectangle is going to go from 3/4 to 6/4, which is 3/2. 6/4 plus 3/4 is 9/4, right? And 9/4 plus 3/4 is 12/4, which is 3. Where am I going? Yeah, that works beautifully, from 0 to 3. So how tall is this first rectangle going to be? If I'm using left endpoints, how tall is it going to be? What's the left side of that first rectangle? 0. So it's going to be this tall. Shiboo! Not that far over, Jeff. And so the left side of each of these rectangles determines how tall they are. So that's how I'm going to draw them in. Looking at it visually